Welcome. In this video I'm going to show you how you can perform a one-way ANOVA in Excel, not using the data analysis function. That one will be faster but will only give you a static result. That means that if you change the values it won't be reflected in the output. Unfortunately though, building a dynamic one, so there's no straightforward function for it. So I'll prepare the small spreadsheet. There are no formulas in it yet, but I've entered these just to show you what the official formula might look like. Let's get started. The first thing we need is to determine for each factor the size. Now with factors in my example, those are the locations. So I have 1, 2, 3 different locations. Perhaps you're using something different, but it's the grouping variable. Now we want to ignore the ones that are empty, so I'm going to be using count ifs. And the first range is up here, and that needs to be equal to this first factor. And the second criteria range is actually my grade, and that one needs to be greater than 0, and that way I avoid any blanks. So I have 16 up here, and I can actually copy paste this simply down and then add the total as well. So in total I have 48 cases to work with. We also need to determine the average for each factor, so luckily there's a function called average if, and we can simply say the range is again these, semicolon, the location is up here, and we want the average of these. And we can again copy paste this down. Be careful though that the last one is actually the basic average if, and here we say, well, I want the average of these should not be empty, so these should be greater than 0, and the average then of all of these. Then the last column in this is a little bit tricky formulated, but it actually is pretty straightforward. You take the factor size, multiply it by the difference between the average in that factor minus the overall average, and I'm going to be blocking that by pressing F4 with the dollar signs. Close these parentheses, add the power sign, and then a 2 for square. And now I can copy paste this one down. Then we can actually add the sum here, and then we go for step 2, the sum of squares. Now for between, this is simply the one we just calculated, that's this one. Then for within, it's simply the difference between this one and this one. And the total sum of squares is actually the variance multiplied by the total sample size minus 1 times the variance var of the scores, which was b double dot b. And now we can say this one is simply this one minus that one. Now if you want to fully perform this one, you need to actually calculate it slightly different. You need a new column there, which I prepared up here, which will be the difference between the score minus a VLOOKUP of the corresponding location in this table, and that the whole table needs to be fixed. So again, dollar signs among everything, pressing F4 helps there. And I want to see the average, and it needs to be true. Then we close this and we square the result. Now what this will do is it will take 20, and then it will look up 3 in this little table, finds it here, and then subtract the third column there, so that's 47. So it actually is taking the grade minus the average of the group it belongs to and squares that result. It should actually ignore any cells that are empty. So what we'll do is add an if this one is empty, then don't do anything else, do all of that. Yes, that was the warning about closing parentheses. Double click on the autofill handle and it nicely copies pastes it down. Now if we take the sum of this column, C, it should give us the exact same result as we had up there. It's an extra small check you could do, you don't actually have to. We're almost there, the rest is relatively straightforward. The degrees of freedom for the between is the number of categories that we have, -1. The total degrees of freedom is the total sample size, -1. And the within is again the difference, 47 minus 2 would be 45, or if you like, it's the total sample size minus the number of categories. Those two should give you the same result. The mean squares are a simple division of the sum of square minus the degrees of freedom. Same thing for the next one. I can just copy paste, but for clarity I'll do it one by one. And that brings us to the F statistic, which is the division between the two mean squares. Finally, we can get the significance by using a few different options. Fdist is the oldest function. You take the F value and you take the degrees of freedom from between and the degrees of freedom from within. If my computer doesn't crash, yeah. Or you can use the slightly updated function fdist right tail, which is again taking the F value and the same two degrees of freedom, so that should give us the same result. And if you feel like making life difficult, you can say it's 1 minus f dot dist. That's the newer function of the F value, the degrees of freedom of between, and the degrees of freedom of within, and then set to true. And there you have it. That's how you can find the significance of a one-way ANOVA using Excel. Be careful with missing values though, and if you really want, I'll put a link in the description below to this file, which also contains a user-defined function that can actually perform the one-way ANOVA for you. If you don't put any third optional outputs, it will give you the significance. If you use 1 at the end, it will give you the F value, and if you use 2, it will give you the degrees of freedom from between, and with 3, the ones for within. Those are the values that are usually reported, so that's why I made it possible to also get those results. Alright, hope you found this clear, and good luck.